Beyond Emissions podcast by Soligent, the largest pure-play solar distributor in the Americas. Hi, I'm Josh Brumm, Energy Storage Manager with Soligent and host of the Beyond Emissions podcast, available right here on Spotify and also as well at the Beyond Emissions location available at the Soligent YouTube channel. Click on there, like, subscribe, hit the notification bell in the corner, and go down into the comment section and be a part of the ongoing conversation about what it's going to take to create a world that is beyond emissions. Welcome to the show. Another great episode today of Beyond Emissions. We talk about this every single week, and I'm asking you again, audience, type it down in the comment section and participate with us. What are your thoughts? What does a world that is beyond emissions mean to you? What does it mean to you? For some people, it's all about the environment. Maybe for some people, it's about the economy. I've even heard national security being discussed in getting off of a fossil fuel-based economy and to a renewable energy economy. Lots of different reasons why some people, different people might have different views about what a beyond emissions future looks like. But at the end of the day, it benefits all of us in one way, shape, or form, or in more ways than one. And so think about that throughout the broadcast with our guest today. What does a beyond emissions future mean to you? By the way, again, reminding you, we are Beyond Emissions Podcast at the Soligent YouTube channel. Like, subscribe, hit the reminder bell, and comment below. By the way, want to remind you, CALSA, CALSSA.org/join. Click on that. And type in Soligent as your discount code for 10% off of your first year's membership with CALSA, the California Solar and Storage Association, representing over 700 businesses just like Soligent here in California, getting rid of the red tape, protecting your business, helping to write pro-solar laws, energy storage, explaining all of the code updates, everything that your business needs to be successful in the solar and renewable energy and energy storage business in California. Join up at CALSA. Again, CALSSA.org/join. Type in Soligent and receive 10% off your first year's membership. Highly recommend that you do that. Okay, our first guest today, my friend, my brother from another mother, Chip Johnson from Crown Battery. How exciting to have you here, Chip. Crown Battery has been around for 97 years. Am I right on that? Amazing longevity. And for lead acid batteries especially, we talk a lot about lithium these days, but really lead acid is not going anywhere. The most recycled products on planet Earth, super sustainable, all about beyond emissions. And I'm so glad that you're here. Chip Johnson from Crown Battery joining us today on the Beyond Emissions podcast. How you doing, Chip?
I'm doing good this afternoon, Josh. Thanks for having me on. I appreciate the time, sir. Thank you.
Hey, it's open floor today. We're going to discuss a lot of different subjects and go into the mechanics, if you will, the insides of lead acid batteries and what makes them tick, what makes them, die sooner, what makes them live longer, how the return on investment with a lower upfront investment and when properly sized, including your PV array for your solar system being properly sized, you can actually get a very long life out of lead acid batteries. And we're excited to talk about that. Wet flooded AGM, oftentimes, Chip, most people, they say, lead acid when they're referring to wet, and they call AGM like it's a separate animal. The reality, they're both lead acid chemistries. We're going to learn a lot today. Excited you're here. Before we get started, Chip Johnson with Crown Battery here on the Beyond Emissions podcast. Thanks for being here, Chip. Chip, what does beyond emissions mean? You heard me ask the audience, what does beyond emissions mean for you?
Well, for me, Josh, it's a couple of different things. I'm a product of my generation, first and foremost. In my mid-50s now. I'm not going to tell you the exact age these days, but I've crossed over from the mid-50s into the late 50s now. And, emissions wasn't even a word that we talked about back in the day when I was growing up as a kid. We had the smog issues back in Southern California and Los Angeles in the 70s. That was on the news at that time. But for us in the Midwest, where I was born and raised and where I still live today, it wasn't really, at the forefront of our mind. And what's evolved over the last, 15, 20, 25, 30 years now is beyond emissions, to me, essentially means a better way of doing something, of creating power in one way or another. Again, being a product of my generation, growing up with internal combustion as my primary transportation, I've come to realize over the years there's better ways to do things. And the technology that's available to us today for anything to get beyond emissions and to be a cleaner environment, it's as exciting as it's ever been. And I'm looking forward to the things that are coming. In addition to all those other things about environment and green and all those things that I appreciate, I also realize that, these energy sources for beyond emissions really need to be value added. They need to have their own sustainability to them. And there's a lot of different decisions that a customer will wind up making to do the proper fit for them. But the bottom line is that there are so many options out there today for, low emission, non-emission type applications that, the consumer has a hard time, from what I understand these days, really trying to make the decision for what's going to be best for them.
And the main reason that it's hard is because there's so many voices, right, Chip? So many different voices out there saying something different. They turn on the TV and see a commercial of people sitting there eating popcorn with their family, and then the lights go off, but then they go, no, but we have this home battery system by so-and-so. And everything comes back on, and then it says your whole house will run when the grid goes down with our little 6 or 7 kilowatt hour battery. It's like, excuse me. Yeah, that'll run the lights and maybe the fridge for 3 hours, but nobody is being honest out there. I don't want to say nobody. A lot of people are misrepresenting what their products can and can't do. And, customization, maybe I'm wrong, but I don't think I am. I'm energy storage manager here at Soligent, the largest solar distributor, pure play solar distributor in the Americas. We pride ourselves on doing it the right way and supporting our customers. I believe customization when it comes to energy storage in this renewable energy market that's going to help us create this beyond emissions future. I think customization is the key to everything, isn't it?
It really is, because if you look at, if any customer, or not a customer, let's just say any family or person that owns a house, rents an apartment, whatever it may be, every one of those people, as an example, gets a monthly electric bill from their utility. And every one of those is different. And it depending upon what the loads are that need to be serviced, the amount of people living in the home, the geographic location of where the home or the place of residence may be, all of those things play into the variables that can make it very difficult. And, touching on your other comment there about the misinformation that's out there, the internet is probably mankind's greatest invention here so far to date. And as good as that device or that base of knowledge is, there's an awful lot of misinformation being referenced from the web these days on anything above and beyond energy storage. You can look at any topic these days, politics or otherwise, and you're going to find 25,000 different opinions on one different topic, because everybody in the world has a voice now, with the web delivering that voice to everybody else. So I guess my comment about all that summary would be is that if you're looking for a decision to make on anything, your home energy storage solution, what kind of car you want to buy, or whatever it may be, just go to the expert, start with the expert, and then let them kind of provide the direction based on an awful lot of feedback that you as the end user can provide and need to provide to make sure you're getting the proper product, however you're going to be using that product. Does that make sense?
Yeah, it does. It does. And, we're experts. I like to say Joe Pizer, he never says he's an expert, but Joe, you're an expert, brother. He's on board here doing technical sales support here at Soligent. We have many others, Bruce Roush, Kevin Watts. We've got so many, Chris Matessa. Gosh, the list goes on and on. Some of the most amazing minds in the solar renewable energy business out there helping customers. We have experts on board. Plus, we have great experts like you and other manufacturers that are able to provide wonderful support. But it really, it comes down to breaking the simplicity mindset around energy storage just, you can't ask the question, oh, I've got a 3,000 square foot home. What do I need? Well, that's good for sizing carpet, but not for energy. And I'm not being demeaning. It's just the truth. At the end of the day, I'm going to live off grid. What do I need? Or I'm going to have battery backup for just, my emergencies. What do I need? I want to do whole house backup. What do I need? NEM 3 is coming and I want to offset instead of selling it back and I want to use that. What do I need? Again, that's going to be a different answer for everybody. There is no package A, B, C, D. Line them up. That's not how energy storage works. Energy is unique for each individual family, each individual household, like our DNA. And in order to figure out what size energy storage solution, before we even get to what brand we want to offer or match up with that customer, depending on what their needs and goals are, the ultimate thing we have to do for any of those scenarios is we have to figure out what is the total amount of kilowatt hours of energy. Okay, that's 1,000 watt hours as a kilowatt hour over 1 hour of time. It's power or energy over time. So 1 kilowatt over 1 hour is 1,000 watts of energy being consumed in an hour. So how many kilowatt hours total? So if I have a 100-watt light bulb and it runs for 10 hours, then that equals a total of 1,000 watt hours or 1 kilowatt hour of energy burned in a day if that 100 watts worth of lights runs for 10 hours straight. That's how you do the math. And so we have to figure out everything you want to run or everything your customer wants to run, the total amount of kilowatt hours, the total amount of energy that customer needs, whether it's off-grid battery backup, offsetting and for, peak hours of usage at night from 5 to 9, regardless, in that period of time that you want to use a battery, how many kilowatt hours, how much energy, how big does your gas tank need to be? We need to know how many kilowatt hours of total energy do you need usable, available? And then from there, we can oversize to create the right depth of discharge for our different battery options and then match you up depending on what your goals are with the different battery options. That's a long answer, but it's the correct answer, right, Chip?
And then I actually call those steps, Josh, to be honest with you. First of all, I totally agree. Those are actually steps 3, 4, and 5 in my way of kind of looking at the parameter there. Before we even get to that point, as an example, if you're going to go live off grid, you better have an energy budget in mind, like you said, before you begin to make your purchases for all the items that you're going to need. But even more importantly than that, you need to put an energy budget in mind based on reduced usage of what you have been used to living off of if you've been grid tied, as an example. And what I mean by that, I'll give you my favorite opening line here when I'm talking to somebody that wants to go off grid for the first time as an example. I'm a single dad with 3 daughters. I've been divorced for 15, 16 years. But so my kids are grown and gone out of the house now. But during the time when they were younger, I was on that every other weekend shared with my kid's mother. And so on the weekends, I didn't have my kids. Well, hell, if I was living off grid, I could have lived on 2 6-volt golf cart batteries. But the weekend I had my kids, a nuclear power plant couldn't keep up, right? So when you're really trying to put those numbers together for an energy budget, and you, for example, and you really want to go off grid, then you really need to look at energy saving appliances, You need to look at insulation within the home to reduce the amount of energy consumption. And then at that point, provide those real world numbers that you're talking about so that you can build a system around, a realistic system around the real energy budget that's going to be required to be serviced. Does that make sense?
Yeah, it does. And what you mentioned also, you kind of were touching on efficiency as well. So if my example was a 100-watt light bulb, then maybe you should go LED and get a 10-watt light bulb and turn that into 100. So always starting on the efficiency side. And, at the end of the day, it's all about customization. If you are thinking that wow, I'll get this battery system and this inverter and that'll take care of everything. It's almost like just filling up your gas tank 10% of the way and then driving from San Francisco to Los Angeles and hoping you're going to get there. It just won't work. You have to plan that out. When you drive somewhere, you have to figure out how much gas do I need to get me where I need to go. You have to do the same exact thing when you're sizing a renewable energy system. And you deal with this all the time. From Crown Battery with us, Chip Johnson, joining us, Soligent's Beyond Emissions podcast. Soligent, the largest pure-play solar distributor in the Americas. Like this video, subscribe, hit the notification bell, and type your questions in the comment section down below. We're happy to answer those. And we talked about what does beyond emissions mean, but now we're discussing the how. How do we create a world that is beyond emissions? And it's in empowering customers to properly size and design their systems so they actually work, they're functional, and they're truly offsetting the carbon footprint of the mechanized world. It's amazing what the technologies are that are coming out today. But also, let's not forget about the technologies from the past. Some of those technologies are just as viable today in certain applications as they were 97 years ago, right? You're from Crown Battery, and, most people these days aren't flying the lead acid flag. But I actually believe that in so many different applications, especially if properly sized and designed, lead acid batteries can be a great return on investment. Tell our listeners a little bit about Crown Battery and the history there. I couldn't believe the history was amazing. Your current owner, most companies out there are just owned by some investment groups nowadays. And talk a little bit about Crown Battery to our audience, Chip.
Well, Josh, we've got the ultimate American success story, right, at Crown Battery with our current ownership and our current leadership. It's a company, like you said in the beginning here, that's been around for a long time. We were founded as a family-owned business back in 1926. So I think we're coming up on our 97th year of continuous operation. And, the lead battery building business, the lead battery manufacturing business has really, exited the States here in the last 20, 25 years. And Crown Battery is based building lead-acid batteries in Fremont, Ohio, about 20 minutes east of Toledo, if you look on a map, since 1926. So we've maintained our status as a made-in-the-USA manufacturer, and there are very few of those left in the States today. And part of our success has been, over the years with the fact of the niche or specialty markets that we focus on with our particular products. As you well know, there's many different applications for lead-acid batteries that range from starting your vehicle, your internal combustion motor in your car, to an energy storage solution like a renewable energy system, and everything in between, by the way, as well. And Crown Battery for the last 25, 30 years has really focused on the smaller volume segment of deep cycle energy storage. You can imagine the starter battery business for your internal combustion car with all the cars and vehicles that we have on the road today is a massive market, and it is. It accounts for probably 80% of all lead-acid batteries sold here in the U.S. But with that being said, Crown Battery, the vast majority of our sales derive towards the energy storage deep cycle market for applications that are strictly DC powered running off of the battery bank itself, such as an inverter and an off-grid system. So we focus on the smaller overall volume segment of lead-acid batteries with deep cycle energy storage, but we do so with a made-in-the-USA product by a company that's been doing it for almost 100 years now. And then our leadership at Crown Battery is bar none the best. Our CEO is the actual owner of the business. He started as a local boy in Fremont, Ohio, went to high school in Fremont, Ohio, and his first job was pushing a broom on the factory floor back in the mid-late 70s, and he worked his way up through the company through the years until he acquired the business from the founding family in 1996, 1997. And then from that point forward, Crown Battery really began to focus on the niche market of deep cycle energy storage with lead acid as our primary chemistry that we use for battery manufacturing, focused almost exclusively on wet flooded products as well as the sealed lead acid product in an AGM chemistry. So we're really built and we're really focused on the DC powered applications in the marketplace today. And right now, I can tell you, Josh, there's no faster growing market than energy storage for renewable energy systems, both off-grid, AC coupled, and anything in between as well. Whether the end user decides to go with a lithium product or a lead acid product, they've got to make those decisions themselves based on the pluses and minuses of both. But we really feel that energy storage market in the renewable side is really a fast-growing, ever-expanding market and will continue to be that way for a lot of years to come.
And one of the things, by the way, Chip Johnson from Crown Battery with us at the Beyond Emissions podcast by Soligent. You can get Crown batteries drop shipped anywhere in the country within about a 1 week or less lead time. Just reach out to us, click on the link below for Crown batteries from Soligent available right now. So get in touch with us. Most people don't realize this. I mentioned it briefly earlier. But if we're talking about a world that is beyond emissions, we're talking about sustainability. There is no other option available in the energy storage business that is as sustainable as lead acid batteries because of the recycling supply chain. That 98, 99% of all lead acid batteries are recycled back in to brand new batteries, more so than bottles, cans, cardboard, you name it, the most recycled product on planet Earth. That blew my mind when I found out about that, Chip.
Yeah, that is kind of the hidden secret there, Josh, when it comes to lead acid products. I know that the general consumer, when they hear the words lead acid batteries, there's a little bit of a cringe that goes on there at that point. But in the end, if you look at lead acid, the product itself, in terms of its sustainability, it's exactly as you said. It's 98, 99% recycled. Because the lead acid battery industry itself is so mature, I think we're approaching 130 years of that chemistry being in use in the marketplace these days. There's also then a very mature industry to capture the spent core product as well when it's at end of life. And that's the beautiful thing about lead acid with its sustainability, is that when that product does reach end of life, it doesn't wind up in a landfill. It doesn't wind up thrown into a ditch somewhere alongside the road. Because of the fact that there's a mature industry to recycle the product, the core spent product has value. And with that value comes demand. And that demand drives that 99, 99, 98, 99% recyclable number that you mentioned. Because the value associated with that core spent product, the vast, vast majority of spent lead acid batteries will wind up at a recycling facility where then 99% of the individual product, plastic cases, the lead plates inside of it, the rubber separator material, the electrolyte within the battery, all of that, 99% of it is captured, refined, and then used to supply raw materials to build new lead acid batteries.
You know what I love about doing a podcast that's not video related? Well, what I love about it the most is you listeners You love the podcast format versus the video because it gives you an opportunity to listen to something, theater of the mind, while you're driving out to the job site for an hour. You got some windshield time. You know, not everybody's sitting in front of their TV or wanting to sit there and stare at something while they're driving around. What do you do when you drive? You listen to stuff. And that's why the audio format for podcasts are so popular in the world today. So I'm so excited because of that. But also as well, I have a radio background, and if you couldn't tell, and been in broadcasting since 1996. And one of the first things that I learned in the radio business, it's all about the theater of the mind. So why don't we do a little theater of the mind for our listeners here today, Chip? Do me a favor. It'll take some description. Shut your eyes if you want to. Not you if you're driving, right? Not you if you're driving. Beyond Emissions Podcast, Josh Brumm, your host here. Chip Johnson from Crown Battery here with us at the Soligent YouTube channel and at Spotify. Like, subscribe, hit the notification bell, and comment down below so you can be a part of our ongoing conversation. We're about ready to enter into the theater of the mind. Chip, for our listeners who don't, may never have a chance to go out and see your facility and tour it, in Ohio for Crown Batteries factory. There's a lot of quality going on in there. Do me a favor, in a virtual sense. Are you willing to do this? Hold our listeners' hand in a theater of the mind sense and kind of walk them through. If they come into your plant at the beginning of the process, what are they going to see and how does that process go? Walk us through that theater of the mind style, Chip.
Yeah, so it's actually, we do this, and I would direct your listeners here. Our website is crownbattery.com, pretty easy to find. There's actually some clips that we have on our website that will actually cover this process much better than I'll be able to do here verbally. But I would tell you, Josh, like any other manufacturing facility, we're about efficiency, right? We want to get product out in the most efficient, cost-effective way as possible to the designs and the material content that our engineers have spec'd our product to be at. So our factory or our facility in Fremont, Ohio is about 315,000 square foot right now. We probably employ 450 to 500 total employees at the factory building batteries for Crown. And the way that it works from an efficiency standpoint is like you would expect it to with any other manufacturing facility, where the raw material, the lead ingots, the plastic cases that the plates are eventually inserted into, and all of the other individual components that make up the battery essentially come into the front door of the facility in multiple truckloads every day. And then throughout the assembly process, actually before we get to the assembly process, we actually do a lot of the individual component building within the factory under that 315,000 square foot roof as well. And then we have a lot of stock then at that point of the individual components that are built within the factory itself. And then all of that component material winds up on one of our 6 or 8 assembly lines to provide for the finished product. And the assembly line is exactly what everybody would envision that assembly line to be, where we have the empty plastic case to start the process. It goes through a series of 5 to 6 assembly points, automation being our primary goal these days, trying to get away from manual labor where people are actually physically having to handle the batteries and more towards personnel operating robotics and machinery to do the actual assembly process.
And with that, you get more consistency. I remember in my early days in the battery business going and touring certain plants where they were hand welding and everything. And it was bragged upon like, yeah, see, it's hand welded, like that's a good thing. But you don't get the consistency there. You don't, I mean, in batteries, we want consistency. Sorry to cut in there real quick. But when you talk about robotics, in all reality, you're introducing real consistency to the quality of the product, right?
Well, let's face it, Josh, as important as the consistency is that we have a leadership at Crown Battery that really cares about the employees that work in the factory, and the manual processes that you described. It's hard work, man, and it's tough work. It's tough on the body, 8-10 hours a day, 5-6 days a week. And when we can alleviate both the inconsistency of manual labor as well as trying to make the job as easy as possible for the employee in that particular position, it's a win-win all the way around. So we really have had major investments at Crown in the last 15, 20 years about the updating of the automation within the factory, where the heavy lifting, quote unquote, is done by the robotics, by machinery, and we have, well-trained people at that point kind of overseeing the machinery, the robotics, to make sure that everything is within spec. And then as that battery, for example, is working its way down the assembly line, after each one of the 5 or 6 assembly points during the assembly line process, there's an automated quality control process check to make sure that the previous step completed successfully. So the ability to implement and invest in the automation of building the battery has really, like you said, led to a consistency of the product. And that is so important for the type of application that we're discussing here with deep cycle energy storage applications such as renewable energy storage. When you're building a car battery, a lot of the efficiencies that lead acid batteries manufacturers try to realize is how much product can we spit out per 8-hour shift. Because let's face it, when the battery goes underneath the hood of the car and starts the motor, well, once the motor is running, the alternator takes over all of the load that's supplied for the vehicle, right? We don't have that luxury with DC-powered applications. Every bit of energy that goes to a DC-powered application to power the duty cycle comes from the battery bank itself all the time, every time, such as an inverter in a renewable energy system. So we're not allowed to shortcut the build process, the assembly process, the design process, or the material content process of a deep cycle energy storage battery, because if we begin to shortcut any of those items, it shows up immediately in poor application performance, and we just can't have that with our product. It's not going to happen.
And then the next step, the automation process, you're able to do everything in a precision manner.
Yep.
And then, so what happens? Talk a little bit about the grid structure and the quality of the innards of Crown Battery as well.
Yeah, so you're talking down to the individual component, and those components are the components that the vast majority of the end user of the product is never going to see, because those are the components that are down underneath the cover of the battery itself that is never removed, right? So to us, at Crown Battery anyway, we're much more about talking about the innards of the battery, as you described, which is a pretty accurate description, by the way, the grids and the plates and all those things that make up the difference of how the battery is truly going to perform once it's in a specific application. The more, for example, that any manufacturer, doesn't matter which one it is, shortcuts on the amount of grid material that goes into the foundation of what turns out to be the battery plate within the battery itself, is going to lead to a shorter life product versus a manufacturer who uses a thicker grid or a thicker plate design will lead to a longer lasting product. So when you're looking at, I'll give you 2 part numbers here that don't mean much to the general audience probably, but you give you 2 L16 size batteries from 2 different suppliers. Well, if you put those 2 batteries on the counter side by side, cosmetically they look the same because they're the same physical footprint, length, width, and height, terminal configuration, voltage, and maybe even their capacity might be relatively the same as well. It's though what happens inside of the battery with the grid content, the material content within the plate, the thickness of the intercell connectors, all of those things that have a direct impact on how well the battery is going to perform and how long it's going to last is what's the most important part to the consumer making the purchase. And unfortunately, those things don't get talked about a lot because cosmetically, when the two batteries are sitting side by side on a counter somewhere, they look the same. They must pretty much operate the same. So what's the price difference? And that's generally speaking how the consumer makes their decision. You really need to drill down into what's inside of the product that really makes it what it is, who's building it, where it's coming from. Is it an automated build? Is it a manual build? All of those things come into the equation at that point, and those are the things that will really drive the decision-making process for the consumer when it's time to make that purchase.
And shortcutting on different chemical factors. For example, some companies out there, investment owned, I won't name names, but they're common brands. They have lessened the amount of antimony in their batteries, which at the end of the day can lower life cycles. It's a component that's not cheap. And it's something that other company, you're not cheapening the process. You've still got the same great quality going into every Crown battery. And I love that. I love that very much. Explain to our listeners real quick. You had a great, again, theater of the mind. Crown Batteries, Chip Johnson with us today, talking about lead acid battery 101. I'm so glad you're here to do this because most people aren't willing to do presentation on lead acid batteries these days, and I think it's so applicable and so necessary, especially for our listeners that are solar installers and contractors and dealers around the country. You know, there's still a need for lead acid batteries. They're not going away. There are still many applications where it's perfect, especially in some off-grid applications, et cetera, where it might be up front. The investment might be a little less that they have available. Well, we can make something happen there. Also as well, longevity of properly sized, et cetera. You can get a good life cycle and good return on investment with lead acid batteries, and it's totally sustainable. More lead acid batteries are recycled than any other product on planet Earth, and I'm not kidding. Literally any other product on Earth, the most recycled product on planet Earth is a lead acid battery. So if you want to be sustainable, it's a really earth-friendly product as well. But what I'd like you to do, more theater of the mind. Chip Johnson with us from Crown Battery on Beyond Emissions by Soligent podcast. What I'd like you to do, more theater of the mind. You had a great graphic the other day where you showed the charging and discharging process, how it works internally, chemically. It's chemical storage. And through this process, that's how electricity is released and discharged. And then through the charging process, that's how the energy then gets stored back in the battery again. It's all done chemically. Talk about that process, charge, discharge. What does that look like chemically inside of a Crown lead acid battery?
And it's not even just Crown lead acid batteries, Josh. The process that we covered the other day is applicable to any lead acid chemistry type product, whether it be wet flooded, whether it be sealed AGM, whether it's built by Crown, whether it's not built by Crown. The best part about the description that I'll provide for you here is that it's applicable to any lead acid product in the marketplace today. It's the way, the chemistry that we've designed and built products around as an industry and has led to where we're at today with lead acid as the predominant energy storage solution still after all these years. But so I guess the best way to start this point of topic here would be is that a battery is nothing more than a device that stores energy in the chemical form that is released in the electrical form. And to kind of preface everything that I'm going to say here with probably the most important comment that I think I can make here today would be the fact that when you're looking at a lead acid battery from a chemical standpoint, it will provide the most real-time, accurate, quote-unquote, state of health of the product versus any electrical reading that you will take from the battery, whether it be a charge control meter from, an off-grid system, whether it's a battery charging platform from a low-speed electric vehicle like a golf cart, all of those things are relatively accurate, but when it comes to the chemical side of how the battery's state of charge, state of health is, chemically is probably the best and most accurate real-time way to read that information or data off of the battery. And that's done with an old-fashioned battery hydrometer. Of course, we're talking flooded lead acid product here because we don't have the ability to use a battery hydrometer with sealed products such as an AGM technology. So we'll limit it to that at that point. But essentially what happens with any lead battery that is creating power, it is basically a chemical reaction occurring inside of the battery that produces that electrical current. In the battery industry, we call that acid transfer. And at a very high level, essentially what is happening is that the battery is fully charged before it starts a discharge cycle. What happens when the load is applied to the battery is that the acid portion of the electrolyte begins to migrate into the positive plate material within the battery, and that continues for as long as the battery is discharged. And then that bonding of acid with the material on the positive plates within the battery creates current within that battery plate, which is then carried out of the battery through a series of welds and connections to power whatever load is being applied to the battery at that point. That process, doesn't essentially stop when the load stops, because that process actually continues when the battery's just sitting on a shelf with no load being applied. It goes at a much slower rate, but nonetheless, it's still happening. The process then reverses itself when a charging platform, solar panels through a controller, a battery charger on a low-speed electric vehicle, for example, pushes current into the battery, and then that current breaks the bonds between the acid that has bonded with the material on the plate and pushes, quote unquote, the acid back into the electrolyte that makes up the cell of the battery at that point. That is essentially the chemical process by which the battery is discharging, producing current, and then recharging, accepting current as it's being recharged from whatever charging platform that's being applied to the battery at that point. That process is a wear process on the internal components of the battery, primarily the plates. And what we do as a lead-acid battery manufacturer, and I'm sure most other lead-acid battery manufacturers have the same mindset as well, is that what can we do as a designer and builder of lead-acid batteries for the internal components of the product to best withstand the wear process of acid migrating into the plate during discharge and then being pushed back out of the plate during recharge. And trust me when I tell you, there's been many millions of dollars spent over the decades that lead-acid batteries have been in service to best improve that process, and it's not stopped yet. So when you look at lead-acid, if you're an end-user consumer looking at lead-acid as a potential option for energy storage, I guess my best advice is that where we're at today, we're as good as we've ever been, with no dispute to that whatsoever. And on top of that, we're always continuing to look to improve the efficiency of the product to get through that with even longer duty cycles, more cycle life, more energy per plate, which raises our energy density. It's a constant work in progress trying to tweak the product to get it to higher and higher levels of performance, longevity, as well as capacity.
So as the battery, the lead-acid, wet-flooded lead-acid batteries being charged, it is then releasing the bond of that active material back into the electrolyte solution, which is why when a battery is more charged than not, it has a higher specific gravity, correct? And then as it's being discharged, it's bonding to the plate. Hence, in the electrolyte solution, there's a lower specific gravity, which specific gravity reflects voltage levels as well, which is why chemically with a hydrometer, you can really, really get to the exact number of what your state of charge truly is with wet flooded lead acid batteries. Am I correct in that? Did I hear that correctly from you?
Absolutely on point. And that's the biggest, not the biggest, but that's one of the issues that we face as a lead battery supplier for people who own and try to maintain their lead acid battery bank, is they're trying to interpret the information that the hydrometer is giving them when they're testing their batteries. And just like you said, the hydrometer readings of a battery go up and down as the battery is being recharged and discharged, right? They coincide with voltage on the charge control meter, as an example. The biggest issue that we have is that when those readings get out of balance with each other, the charge control meter might be showing that the batteries are at float, but your hydrometer readings might be showing 50% state of charge at that point. And in every single case that I can think of off the top of my head, the hydrometer supersedes the information that you're getting from the charge control meter. So if your hydrometer is indeed telling you that the batteries are only at 50% state of charge, the batteries are indeed not fully charged and need more current to fully top them off. That's how important the hydrometer is to a wet flooded product in terms of properly keeping the batteries maintained and, as you mentioned, out of a partial state of charge environment, where at the end of each discharge cycle, the batteries do get to a fully charged, topped off environment.
I'm glad you mentioned it. Partial state of charge. There are a lot of buzzwords being thrown around out there, carbon being one of them, and manufacturers claiming that this is a partial state of charge battery. No, it has some carbon added to the plate, which allows it to be a little bit more resilient, maybe 10 or 15% more resilient than a plate that doesn't have carbon added to it. But at the end of the day, every lead acid battery will have sulfation damage eventually, whether it's 10 to 15%, later on or not. It's going to have partial state of charge damage and sulfation damage if the lead acid battery is not being fully recharged 100% every cycle. It's so important. You talked about that in a training that we did the other day as well, that's probably the number one, cause for failure in a renewable energy wet flooded lead acid battery application is, I mentioned it, undersizing the PV array, basing it on, average kilowatt hours used, divide by 5, boom, there's the PV array. No. You have to oversize to account for all the inefficiencies. Lead acid charge is a little bit different. The acceptance of the electrons. Talk a little bit about that. We want people to get and maximize the life of their investment when they get a lead acid battery.
Yeah, so there's no probably about it, Josh. The bottom line is the number one premature killer of lead acid batteries is the batteries operating in a partial state of charge environment for an extended period of time. And it leads to everything that you pointed out exactly, with sulfation, which is shortened cycle life, diminished capacity, and then unfortunately premature failure. What I would tell you is that there are very simple steps to resolve that before it becomes a major headache for a person with a lead acid battery bank that they're using, for example, in an off-grid system. And what we're trying to do is that, from a very basic formulation, whatever you take out of the battery during the discharge cycle, lead acid batteries are about 90% efficient when it comes to recharging the battery after the discharge cycle has ceased. And that essentially means that whatever you take out of the battery during the discharge cycle, you've got to put approximately 110% amperage back into it again of amp hours removed from the battery during the discharge cycle. Now, most charging platforms, unfortunately, are voltage-based, not amps out, amps in based, and that can be a very difficult number, to try to track at that point then. If you don't have any kind of monitoring system that shows you the amount of amperage being taken out of the battery bank during the discharge cycle, and then what's put back into the bank during the recharge cycle, The hydrometer then becomes your best friend. And that is very simply applied in the manner that when the charge control meter is telling you that the batteries are at float voltage, the specific gravity readings of the cells of the batteries with the hydrometer at that point should be 100%, which is approximately 1.265 specific gravity when the batteries are fully charged. If the batteries aren't exhibiting those specific gravity readings, when the voltage is showing float, the batteries are out of balance, and at that point, you need to equalize the batteries until that specific gravity number is achieved, which then puts the batteries back in balance chemically versus electrically. Does that make sense?
It does. It does. And I would add for our listeners, especially if you're installing batteries out there, folks. Thanks for tuning in. Chip Johnson from Crown Battery with us today on the Beyond Emissions podcast by Soligent. Crown batteries available anywhere in America, drop shipped within about a 1 week lead time from Soligent. Click on the link below. The key to making sure that you don't have batteries, lead acid batteries in a partial state of charge environment and experience the damage that Chip described and have to go through all of the after the fact stuff is to do it right up front. You mentioned, for example, you need to oversize whatever energy is coming in by about 10% versus what got taken out, right? And
that
so,
is correct.
yeah, so you want to, for the inefficiency of the battery, you want to account for about 10%. So then also as well, let's say you also want to account for the inefficiencies of everything else that's included. So 10% plus the 4% for the charge controller, plus the 6% for the inverter, plus the 10% or 12% or whatever it is for, the solar itself. Oh, wow, we're at 40% now, right? So, okay, so the average solar company out there that is brand new, and I'm glad we're talking about this right now because this will help you folks get the most life expectancy and maximize your customers' return on investment with these lead acid batteries. It's not a bad technology. You just have to know what you're doing, and that's what we're here sharing with you today. So, for example, instead of just doing the average size of the PV array based on the energy consumed by the customer. So let's say the customer consumes, 40 kilowatt hours a day of max energy consumed. Okay. And so, by the way, we can go into this in a second. We want to oversize the battery bank as well so that it's not discharging at 80% depth of discharge and only lasting 2.5 years, at 400 or 500 cycles. We want to help them maximize life. So the less you discharge a lead acid battery, the longer it lasts. So you want to oversize it by like 70% in an off-grid renewable energy solar application. So you want to take whatever your energy consumption is, say 40 kilowatt hours, and you want to increase that by 70% so your battery's at 30% depth of discharge, maximizing the life expectancy. That's the folks that are getting 10, 12, 15 years life out of their lead acid batteries. This is what they're doing. So 40 kilowatt hours divided by 0.3, that increases by 70%. That's 133 kilowatt hours. Watts divided, 133,000 watt. So kilowatt hours is 1,000 watt hours. So 133,000 watt hours. Watts divided by volts equals amps divided by 48 volts. Let's see here, 133 divided by 48 is 2,770. So 2,500 to 3,000 amp hour at 48 volt lead acid battery bank. But let's go back and now size the PV array to make sure that battery is not in a partial state of charge environment. By the way, we're doing this for 1 day, not for multiple days. So we take 40 kilowatt hours and we need to increase that by 40% because the 10% for the battery inefficiency, and then we accounted for the inverter, we accounted for the inefficiency of that, the charge controller, and the PV array. So we need to oversize that by about 40%. So divided by 0.6, that'll increase that by 40%. That's 66.66 kilowatt hours divided by 5 hours of peak sun. That's a 13.3 kW array, PV array needed. So you need about 13 to 14 kW of PV array needed in order to make sure that that 2500 amp hour 48 volt lead acid battery bank we sized is not in a partial state of charge environment. That assumes sunshine every day. So you need to have a generator and a good inverter charger system for when it's not sunny outside, because it's vital to get that battery always fully charged every time. But we can do all that up front with math, right, Chip?
Not only can we do it with math, I'll go one step further than that, Josh, is that all those numbers that you spit out just now, I entirely agree with. And here's the nice part about that. That scenario that you laid out, I live in Southeast Michigan, not a very conducive place for solar to begin with, okay? But let's say that we're talking Denver, Colorado, where 10, 11 months out of the year, we have some pretty good solar. There might be 30 to, a month or two where we don't have not so good solar. All of those numbers need to be applied to the 1 or 2 months of worst case scenario. And then when you've got that type of capacity for your system to address the other 9 or 10 months out of the year that are optimum or more optimum, now you really eliminate all the headaches that you're going to face.
Amen. Amen, Chip. Amen. Yes. So if you're off grid, I divided by 5 hours of peak sun. After we took the total energy, increased it for the inefficiencies, and then divided that by 5 hours of peak sun. That was just using an average, but yeah, I'm glad you said that, because in all reality, you have to base that on not the peak sun average for your area, but your peak. If you're off grid, this is all you got, right? So you've got to take what is the peak sun on the month out of the year where there's the least amount of sunshine available. So December or whatever that might be, right? And that is the month you want to figure out how many hours of peak sun, not sunshine, but peak sun do I have? And it might be 3, it might be 4, it might be 2. You might be up in Alaska and it's barely 1, right? And it really depends. And so you've really got to focus on that as well. Amen, man. You covered all the bases. I loved how you brought that up, because it is so true. You've got to, just like sizing, you've got to take the kilowatt hours of energy a customer uses on a max use day for off-grid. You cannot mess around and do averages with off-grid, right, Chip?
Or you better have one hell of a propane tank there on site to run that generator an awful lot for that 1 or 2 months out of the year in Denver, Colorado, where you're not going to have an awful lot of solar. And some customers, Josh, as you well know, will do that, right? They'll try to save a little bit on the overall capacity of the solar system, invest in some additional generator propane costs to cover them for that 1 or 2 months where solar is not so conducive. But if you're not going to do that, then you better build your solar system to the proper capacity to address your worst case scenario climate, so that the other 9, 10 months out of the year, you're more than optimum at that point.
And in the pretend system we just designed, where let's say we've got a 13 to 15 kW PV array with a 15 kW solar converter, a generator tied in, and about 2,500 amp hours at 48 volts of Crown of quality lead acid battery system. You can get all of those components I just described with the racking included, ground mount or roof mount, from Soligent. Isn't that cool, Chip, that everything we just discussed, we could figure out for a customer, and you at Crown, along with us here at Soligent, we team up to help customers do that math to discover exactly which components and how much of each of those components will be needed to meet their goals. Isn't it so cool that it's like a one-stop shop here at Soligent with all of these great options available and this great utilization of math to customize systems all in one spot, Chip, right?
It is. And you guys already have the expertise, Josh, to get the customer over the finish line for a complete system. But that's the one positive thing, for example, that an internet search engine can provide as well. If I live in Denver, Colorado, or if I live in Detroit, Michigan, what is my amount of solar that I can expect to see over a 1-year period of time? And I can find that answer very accurately and very quickly. When I combine that information with what I get from a Soligent, for example, as a turnkey supplier for a complete system, I'm going to eliminate the vast majority of headaches that I would have had otherwise trying to do it on my own, for sure.
I love it. And I love that you are part of that turnkey complete system available at Soligent. Chip Johnson with Crown Battery. I'm running out of time and I've got to go, Chip, and I've promised me that you'll come back. It's been so much fun having you and just running through the numbers and talking about chemistry and lead acid. We're nerding out a little bit, but I hope you don't mind, listeners. We love our batteries, right, Chip? We're all about it, right?
30 plus years in the industry, man. I'm stuck here now for life. So
That's awesome. That's awesome. We love it. And 97 years of serving the world with quality lead acid batteries, now built at a just brand new, amazing, just all the technology that can make the best consistency, the best people there. At Crown Battery in Ohio, your distribution centers around the country, and working with a partner like us at Soligent, so we can get these Crown Battery solutions to you, the listener, anywhere in the country, drop ship in less than a week. I know that right now, a lot of manufacturers out there are slow poking it, and you try to get some 6-volt, 400 amp hour L16 style batteries, 8 of them for a 48 volt, 20 kilowatt hour system for someone, and it takes 2 months. Now we've got it available at Soligent. Click on the link below, get your Crown Battery solution and get it ASAP. We'll take care of you. Chip Johnson from Crown Battery, you're the man. I appreciate you, brother. Thanks for coming on the Beyond Emissions podcast. If our listeners would like to reach out and talk with you, ask any questions, what's the best way for them to get in touch with you, Chip?
Yeah, absolutely. Email is the quickest. Cell phone too. I got no problem doing that. If somebody wants to get more in depth after an email, I'm more than happy to chat with them. But my email address at Crown Battery is cjohnson@crownbattery.com. cjohnson@crownbattery.com. Folks, reach out to Chip and he can help support you on your technical support, talking through projects. And if you need to order Crown Battery, do it right now. Click on the link below. And we here at Soligent will take care of you. Chip, thanks so much for hanging out with us today on the Beyond Emissions podcast. We'll have you back again. I'm going to hold you to that. And thank you so much, brother. Have a great day. Hang on the line for engineers, sir. Thank you, sir.
Chip Johnson from Crown Battery, brought to you by Soligent today. I'm so thankful that you have joined us every single week. We learn so much. Experts from around the world, different vantage points, different discussions, different technologies, all available right here. And with the mission, that's the how. How we're going to do it is the discussion of these technologies and these experts that come on the program. It's the knowledge they dispense to us on the Beyond Emissions podcast. That's the how we're going to do it. But what's the mission? Yes, the mission is creating a world that is beyond emissions. Every single week we talk about it right here at the Beyond Emissions podcast on Spotify and at the Soligent YouTube channel. Like, subscribe, comment, hit the notification bell as well. Be a part of our program and the ongoing conversation about creating a world that is beyond emissions. The Beyond Emissions podcast brought to you by Soligent, the largest pure play solar distributor in the Americas.
We at Soligent are incredibly excited to announce our partnership with GivePower. Well, we wouldn't be here today talking to you about GivePower if it wasn't for our partners, LoanPal. They've been with GivePower since the beginning. Their contribution has given water and light to countless people across the globe. We are truly inspired by LoanPal's dedication to the cause. Something LoanPal said really strikes a chord regarding GivePower, that this is something that's more than money. It's what makes making money more worthwhile. In a lot of ways, that's synonymous with what we're doing here at Soligent.
Here's how you can help.
What we've decided to do is compound LoanPal's contribution by donating to GivePower on every order paid via our direct pay program through LoanPal. That's right. Every time your company uses your LoanPal portal to pay Soligent for material, 5 people get clean drinking water for a full year.
Together we're stronger.
Together, we can choose to be extraordinary by giving to people who live outside our reach. To us, this means a lot.
Soligent's purpose meets GivePower's mission. Join the impact. Soligent, Solar Engine. SolarEngineSolutions.com. Go there to find out more. CALSA, CALSSA, stands for California Solar and Storage Association. Join over 700 companies, including Soligent, and become a CALSA member today. Go to www.calsa.org/join and enter Soligent as the discount code and receive 10% off your first year. Membership starts as low as $500 per year and covers you and your entire company. You can pay in monthly installments or once per year. Why join CALSA? For over 40 years, CALSA has been fighting for your rights in California. If you're an installer or contractor in California, it's CALSA working behind the scenes on your behalf to protect the solar and energy storage business you and your companies rely on each day. Imagine the utilities are totally unchecked without CALSA fighting for you. CALSA fights for your rights and also provides resources like direct one-on-one support from their experts to help you with your questions, navigating everything from NEM 3 to battery fire code compliance. CALSA will help you and your company to stay up to date on the latest policy changes that impact the California solar and storage market and your bottom line. Joining CALSA helps to fund their work to lobby for cutting solar and storage red tape, pass pro-solar laws, and to defend your business from attacks. Become a CALSA member today at www.calsa.org/join and enter the discount code Soligent to receive 10% off your first year. CALSA is fighting for you and your business. Join over 700 companies like Soligent and make a difference in the California solar and energy storage market today.